Okay, as promised, this is the video that I will cover construction of the Mark II battery adapter. Now, before anybody asks, there was a Mark I. It wasn't as good as this one I've shown you. It could only do a few batteries, where this does many more batteries. More versatile. So without further ado, we're going to get into construction of all these pieces. And there are some specialized tools and techniques that the average person probably will not have access to. You're going to need access to a lathe. And since if you don't have one, well, you're going to find somebody that does. Maybe buy them a case of beer, talk them into making this for you. Or heck, maybe even they want to make one for themselves. Alright, let's get on to the first step, which is materials. The first step in materials is getting our tubing. Now, PVC tubing used for plumbing here in America comes in a lot of sizes and a lot of colors. But for our purposes here, the easiest to get is the white PVC Schedule 40. Schedule 40 stands for the thickness of the wall. Okay, and from top to bottom, if you can't read this clearly because my handwriting ain't the greatest, we have 1 inch Schedule 40 PVC. This is a 6-inch piece, or 152.4 millimeters in length. 3/4 inch Schedule 40 PVC, 4.5 inches long, or 114.3 millimeters. And 2 pieces of 1/2 inch Schedule 40, 4.5 inches long, or 114.3 millimeters, and 1/2 inch PEX, 4.5 inches long, or 114.3 millimeters. Now, PEX pipe is it's like PVC, but it uses different methods to hook it up in houses, and it comes in a lot of colors as well. Like here's white, and here's blue and red, and blue and red is just for like cold water, hot water. So this is the pipe you're going to need to build one battery adapter, all these pieces. Now the first step is taking this pipe and all but one of the 1/2 inch pieces, we're going to set that aside, but taking all these pieces and turning them down so they fit inside each other. As you can see here, it's pretty close to fitting in, but not quite. And the 1/2 inch is pretty close to fitting into the 3/4, but not quite. And then the 1/2 inch PEX is really close to fitting inside of the 1/2 inch Schedule 40, but not quite. So you want to turn this down on a lathe so it fits in there, turn this down on a lathe so it fits in there, turn this down on a lathe so it fits in here. And I'm not going to show you my lathe and me doing this. I'm sure you can find videos online of people turning stuff down on a lathe. It's not that complicated, but that's the first step. The gray PVC pipe. Now, the white PVC pipe and the PEX I was showing you, that's all in the plumbing department of your local hardware or home improvement. This gray PVC, however, is in the electrical department, and it's used as electrical conduit. You can see conduit right here on this piece written. And it's roughly the same dimensions. Using a vernier caliper, I have noticed the dimensions aren't exactly the same between the white and the gray. So if you decide to make a battery adapter, you really got to pay attention to what you're doing. You'll also need some 1/8 inch thick ABS plastic or PVC, whichever you can get. I have quite a bit of this in my shop. I've used it for a number of projects, so that's what I had, that's what I used. Now, for those people in countries that are not using the inch system, when I say 1/8 inch thick, I actually mean in metric 3.1750 millimeters thick. So it gives you an idea on the thickness. Alright, while you're out shopping, if you don't already have it, you're going to need some slating nails. They're made of copper, 100% copper. They're a little pricey. I had these, like I said, laying around. Everything I used to make my battery adapter, except for the springs, I had laying around my shop. So it's kind of funny I have all this stuff. But slating nails, these are 1.5 by 11, number 11s. They're about almost $10 a box, so pretty pricey. You're going to need some 1/8 inch stainless steel rivets and some 1/8 inch copper rivets. So add that to your shopping list. You're also going to need some copper sheet. This particular piece of copper sheet was left over from when a friend of mine had his house done in copper shingles. And instead of throwing away all the little bits and pieces, I filled up basically half a garbage can and my friend gave them to me. And I found numerous uses over the years for this stuff. So that's what this copper is. It's a very thin gauge. In fact, we're just going to measure it with my little digital caliper, veneer caliper. And in the inch scale, 0.032. And in metric, it is 0.59 millimeter. So if you don't have some convenient like I do, you're just going to have to go by a hobby store or a good hardware store and get yourself some sheet. You don't need very much if you're only going to make one battery adapter. In fact, out of this piece, I probably have enough here to make 3 different adapters if I wanted to. Okay. So here we got our pieces that we've turned down. This is our inch piece, which makes up the main body. This is our 3/4 inch piece, and now they fit inside each other. This is our 1/2 inch Schedule 40 piece, and it fits inside the 3/4. And our 1/2 inch PEX, which fits inside that. So everything fits inside of it. Now what we need to do is we take our 1/2 inch Schedule 40 that we've not turned down and the 1/2 inch Schedule 40 that we turned down. Now, this is going to get bored out. The inner diameter is going to get bored out to a larger diameter, and then this gets turned down to fit inside there. This piece that gets bored out becomes our main internal adapter body. And this piece will become our AA adapter sleeve. So we're going to go on and go to that step, and I'll give you some rough measurements for this. Another thing I forgot to mention in the video was the dimensions of the main body. So once you get all your pieces of pipe turned down to where they'll fit inside each other, you want to take your 1 inch PVC, you want to cut a piece that is 1 3/8 long from shoulder to shoulder, and that is 34.925 millimeters. And then you want to cut your main body piece 3.5 inches, which is 88.9 millimeters. Then what you want to do to the main body is you want to turn down the shoulder, add a little chamfer to it. You don't want to turn down more than 1/4 inch right here. And 1/4 inch in metric is 6.350 millimeters. And then you're going to want to take your main body and you're going to want to bore out enough material for that to seat firmly. We're back and we have our pieces turned and cut to length. Now the length you're going to want to cut both these pieces to is 3.25 inches or 82.550 millimeters. And just to show you, they fit inside of each other quite nicely. Now, the larger diameter that we're going to use for the main insert inside, you want to chamfer this edge. You can see I add a little chamfer to it. And then this piece, when it goes in there, you can see you got a little gap now. So what we're going to do is we're going to use a cigarette lighter. We're just going to heat up this PVC just a little bit. And don't worry if it looks like it's burning a little bit, ain't no big deal. And then we're just going to spread that out well, it's still malleable. Now, the whole point of doing this is so when you drop that sleeve in there, it doesn't fall all the way through. And like I said, I got a little discoloration right there where it looks like it burnt a little bit. I'll just fix that with a little bit of sandpaper later. But as you can see now, it fits quite nicely and doesn't fall all the way through. So, dimensions, the boring dimensions. I got my digital caliper here. The inner dimension we bored this out to was roughly 0.6955 inches, or in metric, we'll switch it over and remeasure it in metric, 17.29 millimeters. And then this body was just turned down just to fit inside that real nicely. So, on to the next step. Our next step is we want to take our 3/4 inch piece of PVC that's been turned down, and we want to cut an inch piece off of it that's all squared up, or 25.400 millimeters, and then we want to cut a 5/8 of an inch piece, or 15.8750 millimeters. And then the shorter piece, the 5/8 piece, we want to chamfer the outside, as you can see right here. And then our next step is gluing this up. Now we're ready to start gluing. Now, the first piece, you got to make sure you hit the chamfered edge, the inner chamfered edge, that's your top. And you want to glue this piece 1/8 of an inch from the end. In order to do this and not make a huge mess, I use Q-tips, and then I can discard the Q-tips when I'm done. Also, a note about the glue and the primer. This stuff is very, very, very smelly, and it's not good for you to inhale those fumes, so if you're going to do some gluing, do it outside. I'm doing it in here real quick just to show you how I do this and how I get a really nice glue up without a big mess. So here we go. First, we take the primer. I dunk a Q-tip in it. I just run it around here a few times. This basically just cleans up any oils or anything that might be on the pipe, so you get a good bond. Okay, next I take the glue on a Q-tip, and I work it on here. You don't need a whole lot. Glue, cement, whatever you want to call it. Some people are going to get upset because I keep calling it glue when it actually says cement on the package, but hey. Okay, so then I discard that one in the trash. Now to get 1/8 of an inch, I'm using a square here as I push this up. And boom, that's where I want to stop. Now, cleaning up the excess glue. We'll come around here with another Q-tip. And I'm going to clean this stuff up. Discard that one. Another Q-tip. The whole time I'm doing this, I'm not pushing it down either. Now, you'll see there's still some gobs of glue stuff there because it's starting to set up. How do you get that off? Well, you take a Q-tip, you take some more primer. The primer actually acts as a solvent, and you can clean that excess glue right off. It'll come right off. Yep. Clean it all up real nice. I can get right in there. Discard, go to another one. I need some more solvent. And basically you just do this until you're satisfied with the finish. I've almost got it where it's good enough for me. I'm not going to complain because I got a little stain right there. I mean, who's going to see it besides me when I use it, and I'm not worried about it. So, Go around here one last time, make sure I got all my stray glue. Go check, make sure I'm still, yep, 1/8 of an inch. And we go to glue the next one. Now we're ready to glue on our inch piece, and we measure 1/4 of an inch from this end, and that's all we want to glue on there, or 6.350 millimeters. And the 1/8 inch measurement is 3.175 millimeters. So let's go ahead and let's do it. And for this time I'm just going to use it on the inside of the pipe. There we go. And I've already treated this, there we go, right up to my measurement, with the primer. I'm just going to go around here and clean up any pieces. I don't really see any. Turn it around inside, do the same thing real briefly. And this is just for aesthetic reasons. You don't really have to do it the way I'm doing it. And I'm not going to show you me gluing every piece on here. This is the only part you're going to see with me gluing. So when I say I'm gluing something up, unless I'm using super glue, which I will state, this is how I do it. Now, we just let this set. I like to let anything I'm gluing like this set overnight so it hardens up real good. So, on to the next step. Next step, we're going to take our plastic or ABS sheet that is 1/8 of an inch thick, and we are going to cut a piece that's big enough. It's really hard to see here, but there's a 1-inch circle drawn on there. And we want to drill a hole dead center of that 1/8 of an inch. Now, this is a 540 bolt. It's an English measurement. I'm not sure what a similar bolt in metric would be. And it's got a locking nut and a washer. And basically you take your piece when you have it at this point and you secure that on there very tightly. Then use a pair of shears or aviation snips, and you don't want to get too close to the circle you've drawn. You just want to take some material off there, chuck it up in a lathe, spin it, and bring it down to where it is the correct size to fit inside of your pipe. And you want it to just fit, and that just fits in there. And you're going to need to make 2 of those to go on to the next step. The next step is to take your battery adapter. Here I've switched to a gray one that I got more done on than the white one. And you want to cut a 1/4 inch piece of the 3/4 inch PVC that you've turned down, or 6.350 millimeter piece. And you want to glue it in the end. That's the opposite side from where you've chamfered for your lid. And you want to glue that in at a depth of 1/8 of an inch, or 3.175 millimeters. And how you get that is you just use a little bit of cement glue. You take your pre-made disc and you use that as a spacer on a flat surface. Do that, then pop the spacer out, because you don't want to glue that in there right now. Clean this all up with some Q-tips, and then let that harden up. And you're ready for the next step. We want to make the stainless steel contact plate like shown here on the original. So it's a lot like how we made the plastic inserts like you see right here. You take a piece of stainless steel. I'm using 22 gauge. I have no idea what that is in metric. 304 stainless steel, and you basically mount it on one of these 540 screws with a locking nut, and you spin it on a lathe till you have a round piece. Then I just hit it with some sandpaper here to make it kind of decorative, and here I got a couple made. You only need 1 per battery adapter, but It's pretty simple, straightforward to make. So on to the next step. One of the things I neglected to mention when I shot the original video was the diameter of the stainless steel discs, which make up the main contact plate on the back of the battery adapter. And basically these are 1/1/8 diameter, or 28.575 millimeters. And here I have one on a bolt with a piece of ABS that'll fit right inside this piece of pipe. So you see, it's just a little bit bigger diameter than the hole in the pipe. And that's basically what you want. So when you go ahead and assemble, you got a good contact area for your battery adapter. For the next step, you need your copper sheet, and you need a punch and die set capable of going up to 3/4 of an inch, because we want to cut, as you can see here, I've already done it, we want to cut some 3/4 inch discs, and I've already done it. There's my disc. I'm all good to go. And you can use these with a soft-faced hammer. You know, you just put the material in here and you hit it hard. I mean hard. You pound on that and it'll cut a disc. Or you can put it in a hydraulic press and gently apply pressure till it punches through. Either way is good. So the next thing we want to do is we want to take this disc and we want to drill a 1/8 of an inch hole dead center of it. And I'm going to use my lathe to do that, and we'll be right back after I've got it done. Oh, and this set, I got this set at Harbor Freight. It's a really cheap set for, I don't know, I think it was like 20 bucks. Wasn't very much. The part number, Harbor Freight part number, is 95547. We're back and we have our copper disc with a hole in the 1/8 inch hole in the center. Now we're going to take our cone-shaped compression spring and we're going to start a mods. The first mod is you want to take a pair of needle nose pliers and take a little bit of this spring here, and we want to bend that over just like this. There we go, just like that. And that's so when we have smaller batteries in here, like double A's and triple A's, that if they come down here on the center, they make a contact, because this goes in the bottom of our main body of the battery adapter. Whoops, just drop that. Okay, now the next step is we want to prep this surface with flux and little chips of solder, center this, and solder that together as one piece. So I'm going to do that, come back, solder it, and we'll be on to the next step. Back, and we have our flux on there with our little chips of solder. We got our spring, and we just place that as centered as possible. Okay, and we use our torch here to solder it all up. And that's that. She's all soldered up. It ain't going nowhere. Now we let it cool off and we go on to the next step. Now we're on to our next step. We have our spring assembly with the copper disc soldered together, and the flux is all scratched out from the inside so we can make a good metal-to-metal contact. We have our ABS disc, and we have our stainless steel disc and our stainless steel pop rivet. So to assemble this is pretty straightforward. We take the pop rivet, stainless steel disc, ABS disc, push that on there, and spring assembly. And we get that sucker in there. Okay. Put it in our pop rivet gun, and we just hold this all together and squeeze this bad boy together. Okay, got that off the floor, and there's our completed rear assembly, ready to be glued in. And we're going to glue it into this gray one that's ready to go, because that whole thing just glues right in there. So I'll be right back when I finish this and move on to the next step. We are now on to the next step, which we take one of these slating nails, piece of ABS, with a hole drilled in the center, and basically what you want to do is get that in there, put a drop of super glue in here, take a wooden block with a hole drilled bigger than the diameter of the nail, put it in there, give it a good couple smacks with a hammer to where it seats down, and maybe even put another drop or two of glue around this super glue and let it set overnight. Now once this is hardened up, I have another one here that's all hardened up, then you want to take a pair of shears or aviation snips and remove the excess material around the head. Then chuck the whole thing up in a lathe and turn it. And here we get the nice button that you see that's here in the completed one. That's the contact right there. So once you have this done, then we go to the next step. Back, and we're ready for the next step. So we take one of our ABS discs that's pre-turned, and we take our connector made from a slating nail and a piece of ABS, and basically what we want to do is we want to put these two together. So we will get it started like that, set it here in our wooden block. We'll put a drop of super glue in there, not a whole lot, you don't need a whole lot. Put this bad boy down. So once we get that beat down, we basically just want to let that glue dry. Okay, so we'll be back for the next step. Alright, the next step, we have our ABS disc slating nail connector. The glue is dry. We're all ready to go to the next step. And the next step is you go ahead and you make yourself a little copper washer. Here it's like a 1/4 of an inch diameter with an 1/8 inch hole. Now it's a really tight hole because I can't even push it on there. So what we're going to do is we're going to take our block, and on the other side of it I've made a bigger hole to accommodate the contact button. Put it on there, put the washer on there, and I'm going to take this piece of metal pipe and very gently tap that guy home. And that's what we want to begin with. So now that we got this, then we want to take a pair of heavy wire cutters and we want to cut this off. But we want to leave about 1/8 of an inch of material right there. So we go and we take this steel block that we're going to use like an anvil, and we take a ball peen hammer, the round side, and we're going to start working this. We want to mushroom this down. This is how metal workers for generations used to rivet stuff by hand. Just want to every once in a while turn it. Just keep working it. And you don't have to hit this very hard. It's, you know, it's copper. It works rather nicely. You don't have to beat the heck out of it. We're almost getting it where I want it. Okay, so now we've got it pretty much down the level I want. Let you get up here, get a close look. Now what I want to do is these edges, I want to go ahead and fold that over. So I just want to tap right around the perimeter of that. And just keep turning it and lightly hammering away. So we get a nice mushroomed rivet. And then take the flat side of your hammer, just very gently tap it. You just want a good spot for your batteries to make connection. And there you go. That's basically done. Now the next step is gluing that into our head assembly. And we'll be back here in a moment just to do that. The next step, like I said, is we're going to glue this up to make our head. Now the easiest way I found to do this is I got my little wood block here. I go ahead and I drop that in. I take this piece, take my super glue, and the reason I'm using super glue with this instead of the cement is the cement doesn't stick too well to the ABS that you have to use with the gray. So I found super glue is a good alternative. Now I've got the hole coated, press it together, and that's all there is to it. And I'm just going to let that harden up, and we'll be on to the next step. The next thing you're going to want to do is you're going to want to take a doming block and punch set. This particular one I got at Harbor Freight. It was part number 93539. And you're going to want to take a 3/4 inch copper disc with an 1/8 inch hole in it. Or in metric, that's 19.050 millimeters. And a 1/2 inch disc. Don't put a hole in it yet. And 1/2 inch in metric is 12.7 millimeters. And you're going to want to dome these because basically we're building the components here for our adapter spring. And we'll get into modifying the adapter spring here shortly. But first, take your doming block, find the size that the 3/4 inch just fits into. And we're going to start out with a size 16, which fits in there alright. And we're going to start shaping this. And when you use these punches, you're going to want to use a rubber or soft face like rawhide hammer. You don't want to hit this with a steel hammer. You will ruin your punches. Yep, you want to be gentle with these. Okay, we're getting there. Because the idea is you want to dome this very similar to that. So you go to a smaller size hole and we work it. Now I should be pretty close. Yep. So we have the 3/4 inch disc done. Then you take the 1/2 inch disc. We're going to start with that hole right there. And the punch size I'm going to go to is a number 12 punch on this set. basically what we want here when we go to rivet this, we want that to fit down in there and inside the spring very well. Let me get our spring out here. Now this spring is unmodified, it's factory fresh, and it comes pretty far down in there, and that's what we're gonna use. So next step is modifying the spring and putting this all together, and we also got to put an 1/8 inch hole in this little domed guy, and I'm gonna go do that in my lathe right now. Okay, the next step is modifying the spring and completing our spring assembly. So the first thing we want to do is we want to pull this spring apart and make it a little longer like that one there. And we basically want to pull that 2 3/4 inches is what we're shooting for, which is 69.850 millimeters. And just want to do that a few times to get it. It doesn't have to be exact, but the closer the better. Oh, I kind of overshot it right there. And there we go. That's 2 3/4 inches or 69.850 millimeters. The second thing we want to do is whichever side is opposite of the one we rivet, we want to bend the spring in like this so we make sure to make contact with the center of any battery we're doing. And it's pretty easily accomplished. Just pick a side, any side, doesn't matter. I'm going to do this side, and we just get a hold of that sucker and we bend it in. Sometimes it helps to take a screwdriver to it, and of course I don't have a screwdriver at hand right here. I put it somewhere. Oh, there we go. Get that up. Now bend it in. And however you want this to be. I'm pretty happy with that right there. Okay, and we're still at the correct length. So now we're going to rivet this guy together. You take your 3/4 inch domed guy. You take your 1/2 inch. We slip it in here and let it fall down to the bottom. Thread the needle. And take this whole assembly with a rivet gun, and we rivet this together. And we hold on to it so we don't shoot it across the room. And there we go, and you can go ahead and straighten that up. And there we go. And of course that makes it a tiny bit longer than 2 3/4 when we add that copper piece, but that's what we want. There's our adapter spring done. On to the next step. The final step is making the AAA adapter sleeve out of the PEX. Now, taking what you've already learned in this video, you got to make the head that glues inside the pipe. And this head, the only difference between it and the head we made for the main body is we have 2 layers of the 1/8 inch ABS glued together before the head was all riveted, as you can see. And it was turned down to fit inside this pipe. Now, sometimes you have a little trouble getting it in there. At least I did. So I got this reaming tool from General Tool, and I'm just going to ream this out just a little bit, just so I can get it started in there. Okay. And there we go. Now what you want to do is you want to put a drop of super glue on that bad boy all the way around. There we go. And we want to press that guy flush. And the wood block is really good for that. There we go. Okay. And it looks good. It's nice and flush. We just need to let that dry. And once these components are all dry, we're done. Your battery adapter, the Mark II, is done. Alright, we've finished our battery adapter, and the only next logical thing to do is give it a quick test. Make sure everything works. Make sure we didn't mess something up. So, we're going to take the main body, and we're going to go ahead and try our C batteries in it. And they seem to fit okay. Put it in our Fulton flashlight. And, oh, it works. Okay, that's one battery type down. Now we're just going to put in the main adapter sleeve, our spring adapter, and we'll try, I believe this is the 123 battery. We'll try that. And we got light. Okay. So that works. Try the CR2 battery. Put that together. Bada bing, bada boom. And we got light. And last, take the spring out. Put the AA adapter sleeve in, and we put our AA's in. Okay. And we got light. Okay, AA's out. Now we're going to try the AAA's in our little AAA adapter sleeve. Put that all in there. And look at that. I had no doubt that everything was going to work, but hey, you should always check your workmanship. Make sure everything's cool. And thank you for watching. I hope everybody has a Merry Christmas, and like I promised one person, I'd have this video up before Christmas. I think I'm just gonna barely meet that deadline. So, hey, it's my Christmas present from me to all of you. Thank you all for watching. Thank you all for showing interest. Everybody have a Merry Christmas.